Hey guys, all right, so this is the beginning of 11.5. Now, 11.5 is ultra important for you guys in next year in calculus. Okay, now let's just review really quickly. In Algebra 2, when I said find the answers when you add 3 divided by x plus 4, okay, add 2 divided by x minus 3, what would you get? So find the answer means first, when you're adding fractions, you want to find common denominator. So to common denominator, to find the common denominator, you would multiply this side by the other side and vice versa. So this side, I would go and multiply by x minus 3. The other side, I would go and multiply x plus 4. As you now are aware, whatever you multiply to the bottom, you need to multiply to the top. Okay, so this is a 3, this is now x minus 3. Over here, I already had a 2, so now I need to multiply by x plus 4. Now, okay, well, now you have the common denominator. We're going to go a little bit further. On the top, we have 3x minus 9 plus 2x plus 8 all over your common denominator, which is x plus 4 times the quantity of x minus 3. Combine like terms on the top, so that's going to be 5 minus 1. So in Algebra 2, you would say, okay, well, this is my final answer. Oops, 5x. Whoa, almost. Okay. This is x plus 4 minus 3. Now, I'm also going to, some of you, well, can I multiply this out in the bottom? Of course I can. Okay, so if you say, well, that can't really reduce, so I don't need to multiply it out, but some of you love foiling, so you go, I'm going to sit here and FOIL this all out. Yes, I would accept either form. Okay? You can FOIL it out, or you don't have to. Doesn't matter the form that you give me, as long, again, repeating, as long as in the simplest reduced form. Okay? Whenever you're in math class, you got to reduce or simplify your answer. Okay, so that's Algebra 2. Well, partial fraction decomposition, it's the reverse procedure. Okay, what do I mean? So let's just read this really quickly. So look, we have the answer we just found, right? This is the answer we found by adding the two fractions together. This is what we have here. That's what I typed up. The reverse procedure, starting with the rational expression and writing is as the sum, or sometimes we subtract, which is the difference, of two smaller fractions. So all this is how we're going to go backwards, right? If I give you 5x minus 1 divided by x squared plus x minus 12, now your job is just to give me 3 divided by x plus 4, and the other fraction is 2 divided by x minus 3. That's your job for this section, okay? These two are referred to as a partial fraction decomposition. Decomposition. Okay. The two simpler fractions, well, this is supposed to be fraction, there's an R in there. The two simpler fractions are called partial fractions. Okay. Okay, so the process, the reverse process is partial fraction decomposition. Okay. Now, when you get the two answers, so sometimes 3 or sometimes 4, they're called partial fractions. Okay. Now, number 2, rational expression is. Rational has the word ratio in it, so anytime you hear the word rational, ratio is like a fraction, okay? It's in the form of P divided by Q, where P and Q are polynomials. And because Q is in the denominator, Q can never ever be 0. Now, back in the days, and when you're studying fraction, okay, we also had proper fractions and improper fraction, right? So let me just use a different color. Would you guys remember? This would be like 3/4 would be proper fraction, okay? An improper fraction would be 4/3, right? Okay, so same thing here, okay? But we're in polynomial, we talk more about the degree. So in Algebra 2, a proper rational expression is when the degree of P, which is the numerator, is less than the degree of Q, which is the denominator. Okay. Now, improper is when it's bigger than, is when the degree of P is bigger than and equal to, by definition, the degree of Q. Okay. So that's proper and improper. Very similar to basic. When do you study fractions? I don't remember anymore. Okay. There are 4 different cases, and yes, you will have to know all 4 of them for your final exam. Okay. Case number 1, decompose P divided by Q, where Q has only non-repeated linear. Remember, Q is in the bottom, and it's non-repeated linear factors. Remember, linear is with the degree of 1. Okay, non-repeating mean that any of the 2 factors cannot be the same. So what do I mean by non-repeating? Under the assumption that Q has only non-repeated linear factors, the polynomial Q has the form. So Q of x is a minus a subscript 1. Oh, sorry, ax, because this is a factor, times x minus a subscript 2, and then it can be x minus a subscript n, okay? Where no 2 of the numbers, a1, a2, whatever the a's are equal, okay? None of the a's can be equal. Remember, the factors may not repeat. That means it cannot be the same. In this case, the partial decomposition of P divided by Q is in the form of, ready? P of x divided by Q of x is, okay, A1. That just mean any constant, okay? Over x minus your first factor plus some new constant, let's call it A2, divided by x minus the second factor. And you're going to have, can be 2, can be more, okay? Then you can have whatever, how many terms you have, a subscript n divided by x minus a subscript n. Where the numbers, these big a's, a1, a2, an, some books and even later examples, I may use a, b, c. Okay, so it doesn't have to be a subscript 1 or a subscript 2 or a subscript n. It can be a, b, c, d, e, f, okay? Are to be found by you, are to be determined by us. Now, that's case number 1. When the bottom, the bottom is linear and they cannot be the same. Now, case number 2, where Q has repeated linear factors. I mean, it may have some of the same factors, okay? So if the polynomial Q has a repeated linear factor, are you ready? Then what happens? Okay, what does that mean by repeating? Okay, this is x minus a. That's a linear. The reason we call it linear because this is a degree of 1. Okay, so that's a linear, and then it repeats. That means it's like to the second power to the third power. Okay, so where this power has to be 2 or more, and n is an integer, then in the partial fraction, here we go. Somehow, mine is on the next page. Okay, decomposition of P divided by Q. We allow for the terms. Are you ready? Here's the formula. A subscript 1 divided by x minus a plus a subscript 2 divided by x minus a squared, and then it keeps on going, okay? Then a subscript n divided by x minus a to the nth power. Okay. So where the numbers A1, A2, AN are to be found by us. And again, remember, I don't have to use A1, A2, AN. I can use A, B, and C, okay? These are just anything I want to use. Case number 3. What happened when the bottom is not a linear factor? What happened when it's like a quadratic factor? So if Q contains a non-repeated irreducible quadratic factor of the form ax squared plus bx plus c, then in the partial fraction decomposition of p divided by q allows for the term. Ready? So for this one, I'm not using a1, a2, but I'm using a and b, okay? ax plus b divided by ax squared plus bx plus c, where your a and b are to be determined by us. Question number 4. What if you have a repeated quadratic factor? Okay. If the polynomial Q contains a repeated irreducible quadratic factor, such as ax squared plus bx plus c, and then repeating means I can have more than 2 or 2 or more, where n is greater than or equal to 2 and n is an integer. Then in the partial fraction decomposition of p divided by q allows for the term. Are you guys ready? We are going to start with a subscript 1 x plus b subscript 1 all over your very first quadratic, which is ax squared plus bx plus c. Then I'm going to have a subscript 2x plus b subscript 2 all over ax squared plus bx plus c to the second power. And I can have a lot of terms. We don't know how many terms, depending on how many you can break down. A subscript n times x plus b subscript n divided by ax squared plus bx plus c all to the nth power. Where a, b, okay, a1, b1, a2, b2, an, and bn are all to be found by us. So that's just purely the definition. We are going to look at the next video for the example, but this is the end of our definition.